Here's example 6, using an equation of a linear model to make predictions. Again, a linear model is nothing more than an equation that closely represents the data. And so they give us this data in this problem right here, the average salary of college professors at the different years and their average salary in thousands of dollars. Well, they have created this equation, S equal to 1.79t plus 22.50, that is a model or a close representation of this data. So what do they ask us to do? They ask us to verify that the function models the data well. Well, the way we're going to do that is we have to draw two things. We have to draw an equation of the line represented by S here with our graphing calculators. The second thing we'll need to do is draw a scattergram. Now, so there are actually three things we're going to have to do. We'll have to enter the data into a table, into our calculator. The second thing we'll need to do is we're going to need to enter the equation into our calculator. And then the third thing is to draw the scattergram and the equation together. And if the scattergram isn't turned on yet, we need to do that as well. So I guess there could be four things to do. So let's begin by entering the data into a table. This will be a process we'll be doing all year long, so the quicker you get these keystrokes down, the better. Now, when we enter data or information, we're dealing with statistics, and so we will always use the stat key. So I'll press the stat key first. Now, the main two things we'll be doing is either edit or calculate. Right now we're simply editing, we're entering information in, so I'll select that. So I'll just press enter. I have data already there, so I'm going to clear it out. So I'm just going to use the up arrow to go up to L2. Then I'm going to hit the clear button. Let's get that in here. Let me zoom out just a hair. And push enter. So I hit the up arrow to get up there, push the clear button, now push enter and it will clear it out. I'll move up left and up to L1, push clear, enter, and the data is gone. Now, when we were talking about the data, they said since 1980 in the instructions. And so since it was since 1980, 1980 would be year 0. So I'm going to put 0, 5, 10, etc. there. So 0, 5, just push enter, 10, enter, 15, enter, 20, enter, 25, enter, and 27, and enter. Now if I just move to the right, it will go straight to the top, and then I can put in the output values or the Y values. So 22.1, and I'm just hitting enter in between each time, and it moves down automatically. 41.9, 9.1, 57.7, 66.9, 71.4. So step 1 was to enter data into the calculator, so there we have. Now step 2 will be to enter the equation into the calculator. And so I'm going to exit out of this. I'll just do second, quit. And to enter an equation, you've probably done this in Math 70, use the Y equals key. So Y equals. Now I have information in this, so I'm just going to hit the clear key to get it out. Now I don't remember off the top what the equation is. Let me get it real quick. You can see the equation there. It is with an S, but I won't use the S, so I'll just put 1.79 into my calculator. And then to enter the variable, it's T, but it really doesn't matter what it is. This key right here is the variable key. So I'll just hit that, and that gives me an X, but it doesn't matter that that's an X versus a T, plus 22.5 or 50. So now I've entered that. I'll push the enter key at the end so to make sure that it's there. So there's step 2. The next step, I'll exit out of here. The next step will be to make sure that our scatter plot is on, and that is this stat plot. So I'll do second stat plot, and you can see that mine's on right now, but if it wasn't on right here, you would just push enter, and you can turn it on here. Yours might be on off, and then just go over to on, push enter. The fourth and last thing that we need to do to verify that our equation modeled the data well was simply to graph the equation and the scattergram and compare them. So let's do that. To graph a scattergram, you will use zoom. You're tempted to use graph, but it's zoom. And you go all the way down. I'm going to go up because that gets me down faster. And it's selection number 9. Zoom to the stat plot or the scattergram. So zoom stat means zoom to the scattergram or to the information that you entered into that table. So let's go ahead and do that. So I'll push enter here, and it draws a graph of our scattergram, which is the data plotted on a graph, and it draws our equation. So let's quickly go through how we got there. Number 1, we had to enter the information into a table, and that was stat, don't forget. So we use the stat key whenever we have to enter data into a table. And I'll go quickly. Stat, we did edit, and we put it into that table. The second thing we did was we entered the equation. Equations are always entered with the y equals. So we pushed the y equals and entered our equation. Before we actually plotted everything and did the scattergram, we had to make sure it was turned on, which is this stat plot. Because it's in yellow, we have to hit second first. So we hit second, stat plot, and made sure it was on. And then again, once we've done that, instead of hitting graph to graph them, we did zoom and zoom stat. I wanted to leave you with this first part of this problem with what we were trying to do. Again, one said verify that the function s models the data well. And the data was given by the table, and the graph represents the line, which is the model of the data, and the scattergram, which is the data itself. So, yes, it does model the data well. Part 2 would like us to rewrite the equation with the function name f. And so here's the way that would look. Instead of s equals, we would put f sub, and it would be t. T is what normally is the x, or the independent variable, and then f of t is the dependent variable, or the y variable. And so we would say 1.79 t plus 22.5. Part 3 asks us to predict the average salary in 2003. We have to remember a couple things. Number 1, 2003 would be the year. That would be the x value, or the t value, the way we have it written right now. So that value goes right here. However, with our equation, it is since 1980. So because it's since 1980, we would have to do 2013 minus 1980, which equals 33. So we will basically put 33 into that equation, and that would give us the answer. Well, there's several ways you could do it using your calculator, so let's take a look at that. One way, which I wouldn't prefer, but one way to do it would be simply to quit out of this and get back to this spot and simply enter the equation the old-fashioned way, which would be just to type it in. 1.79 times 33. As you can see, we're plugging 33 in for the t, plus 22.5. And we would get that the salary in that year would be 81.57. And I believe that was in thousands of dollars, so it would be $81,570. Now, the way I would have preferred would be to use the table. And so to do that, I would hit second table. And right now I can just simply enter the value of 33 and it would use whatever equation is in my y equals. And notice I get 81.57. Now, that works because I usually have that turned on. If you don't have it turned on, the easiest way is to go under Table Set, and that's the table settings. So it's the second table settings. And normally, this is on auto for the independent variable. Again, the independent variable is the x variable, or the values you're inputting. The dependent are the y values, or the values you are outputting. So normally that's set to auto. So that does have to be moved over to ask. So there's problem number 3. Let's take a look at the final problem. Problem 4 asks us to predict when the average salary will be $85,000. Well, that's simply the y value, or in this case, the s value, or if it was in the f sub t function notation, it would be the f sub t value. So all we would need to do is substitute the 85,000 in for that. But recall that the s was given in thousands. So instead of 85,000, I would put 85 down. 1.79t plus 22.50. So to find when or what year the average salary is 85,000, I would solve that. So I would need to get rid of this and this. To get rid of this, I do the opposite, which is subtract. Technically, it's the inverse operation. And the inverse operation makes it add up to be 0. So it would have 1.79t is equal to this, which would be, let's see, 2 borrow 6250. And the inverse operation of times, because the meaning of 1.79t is times, the inverse of times is divide. And again, the reason we did that was it makes it go away. These cancel. So t equals, and I'll need my calculator on that, and I get 34.9, or about 35 years. Again, that's since 1980. So I would add that value, let's round it up to the nearest year, of 35 to 1980, and get that that would occur in the year 2015. Now, the book says to verify using trace. However, I think table was much easier to use. So let's put 35,000 or 35 in to our table and see if we output 85, which represents 85,000. So we just go into table. You already did table settings. And we had 33 there, now I'll put 35, and notice that gets me approximately 85,000. If I put in a more exact number, what was that, 34.9? Then we get even a little bit closer yet. So there's some rounding errors. So there you have it.